Okay, welcome back. Today we're starting a new unit on waves. This is a continuation of the theme that we've been on. We've been working on energy since the beginning of this semester. Just a brief recap. We started off with speed and motion, but in that unit we didn't really talk about how things got moving. We just described the speed and relative motion compared to a reference point. And then we moved into learning about forces, and forces being pushes or pulls, the law of inertia. And then from there, we moved into how forces allow people to get work done. And the definition of work was a force that makes an object move a certain distance in the direction of the applied force. And we said work was a transfer of energy. So that moved us right into the idea of energy. And we talked about the different forms of energy that people use, chemical potential energy, mechanical energy, electrical energy, nuclear energy. And then we started talking about the different sources of energy. And we talked about renewable sources of energy and non-renewable sources of energy. And then we moved into thermal energy, which is a very important form of energy that people use. And now we are talking specifically about wave energy. And wave energy is incredibly important. Light moves in waves, sound moves in waves. So it's a very big part of the modern world that we live in today. So this first unit is going to be a general unit on waves. And then from there, we're going to move and learn specifically about sound waves and then light waves. And then we're going to finish the year with a unit on electricity and magnetism. So let's get started. The definition of a wave is a repeating disturbance or movement that transfers, and this is the key to the thing, energy through matter or space. So the real, reason why we're studying this is, again, with this theme with energy, it's a transfer of energy. Okay? When waves transfer energy through matter, they pass energy on to neighboring molecules. And they bump into each other, but they do not transport the matter itself. So the wave goes through the matter, but it doesn't take the matter with it. Now, this is sometimes confusing to kids because if you think about a wave at the ocean when it hits you, it sure seems like the water was going along with the wave energy. But this is a little bit different because the wave is breaking, and that has to do with the bottom of the seashore going away and pushing up the wave. Okay, so the energy moves through the matter without taking the matter with it. In the atoms, so then go back to their original positions. Now, all waves are started by something that vibrates. So even the waves on the ocean, the wind blows over the water and it causes the molecules on the surface to begin vibrating. It's a distance, it's the difference between the frequency of the two surfaces rubbing together that starts the vibration, and that's what starts the waves. We're going to take a quick look at this little video from Bill Nye, and he's going to show us how a good example of how waves transfer energy without moving the matter itself. And we're going to take a look at how energy is transferred through waves without moving the matter itself.
You and I see, hear, and think with waves. See, because energy travels in waves, like light travels in waves. Sound travels in waves.
The television picture you're watching right now started out as a wave.
Take a look at this. It's our metal rod wave machine of science. Now, when I move the rod at this end up and down, watch what happens.
Now, notice how the rods of the wave machine he has are going up and down, but they're not actually moving from one end to the other with the energy.
It makes a wave that moves side to side. It even bounces off this end and comes back. Now, a wave like this can carry energy. So watch. I can knock this ball off of here at this end by making a wave at this end.
Now remember, one of the key definitions of a wave is it was a repeating disturbance that transfers energy from one place to another.
See that? Now, different forms of energy move in different ways.
As you saw in the video, when Bill and I hit those rods, they went up and down, and the wave went through the rods down to where the ping pong ball was, and it moved the ping pong ball, so there was a transfer of energy, but those rods returned to their original positions. They didn't actually, the steel didn't actually move along with the wave. Now, those things that the wave was traveling through in the Bill Nye video is called a medium. It's a material through which a wave travels. So not all waves need a medium, but when they travel through matter, the matter through which the wave is traveling is called a medium. Mediums can be solids, liquids, gases, or plasma. And as I just said, not all waves need a medium. Electromagnetic waves or light can travel through space. So if you think about, how the energy gets to the Earth from the sun, there's not air or atmosphere between, after we leave the Earth's atmosphere, between the Earth and the moon, or then the moon and the sun. So the electromagnetic energy travels through what's called the vacuum of space until it gets to our atmosphere. So the electromagnetic waves can travel through space, and they don't need a medium to travel in. Okay, so as I said, electromagnetic waves can travel through a vacuum, like the vacuum of space, which is the absence of matter. Now, waves are classified by the way they move. Okay, mechanical waves are waves that need a medium. Okay, and that's because they have mechanical energy. And mechanical energy is the energy of a system. So the wave, as the whole thing moves, okay, it's the magnetic energy of that whole system of the water, or the air, or whatever the medium is carrying the energy. Need a medium in order to travel. They have to bump into atoms to transport the energy. We're going to take a look at this little short clip on some of the main characteristics of waves and how they travel.
The ocean pounding on the shore. The sound of music. Light emanating from the sun. And the transmission of a television program. What do these things have in common? They are all examples of energy being propagated by waves. Although we cannot see many types of waves, nonetheless they play a very important role in our physical world. We are going to look at the common characteristics and major differences of various waves and show how they are essential to the movement of energy on Earth and through the universe. The waves that are crashing into this rocky headland were caused by the wind pushing against the water's surface. As each wave moves in from offshore, it is transporting the energy of that disturbance.
Okay, so as the air blows across the ocean, the friction between the two fluids, the air and the ocean, cause a vibration, and that's what starts the waves moving in the ocean, is what he just said.
This movement of energy is seen clearly when a stone is dropped into a pool of water. What happens is that the energy of the falling stone makes a disturbance in the water, and that disturbance creates the wave. As the wave radiates outwards, the water rises and then falls, eventually returning to equilibrium.
If you think about it, the water itself isn't going away with the wave. It's not like there's like a low spot in the water all of a sudden because as the wave took the water with it. So when we say it carries energy but not the medium, that's what we mean.
What moves outwards with the wave is not the water, it is the energy of the disturbance. The energy is transported by two basic types of waves, transverse and longitudinal. In a transverse wave, the disturbance is perpendicular to the direction of travel. while in a longitudinal wave, the disturbance is parallel to its direction of travel. But all waves have some...
So as he hits on the head of the drum pops in, and then it creates a rarefaction. When it pops out, it creates a compression.
Common characteristics. The wavelength is the distance of one complete wave. This wave is measured from crest to crest, but it could be measured from any other points.
Okay, so as we said, any point on the wave to any point just like it.
Frequency is the number of wave cycles in a given unit of time. It is usually measured as the number of waves per second and expressed as a hertz, Hz. Amplitude is the maximum difference of the disturbance. Sometimes it is called the height of the wave. Velocity, or the speed of the wave, is the relationship between the wavelength and the frequency. It is found by multiplying the two together. The velocity of the wave is limited by the properties of the medium through which it travels. Wavelength, frequency, amplitude, and velocity are common to all waves, but all waves are traveling disturbances that carry energy from place to place.
Okay, we're going to stop here. I hope you're having a great day, and we'll see you next time.